Okay, so what we're going to talk about today is how data can be distributed, like how it's spread out. And there's a term for that we'll get to of like what it should look like if your data is spread out normally. But when you look at the data distribution, like there's 3 examples on here. They're kind of just showing you how data can be put together. So what data distribution really means is just the way data values are clustered. So you can see there's 3 different options for this. The first one is when most of the data is clustered to the far left of your graph. That's considered to be positively skewed. If the data then shifts and most of it's facing the right side, that would mean that it's negatively skewed. And then that last one, this is what they would consider to be normal. Okay, so normal just being the term of like this is what it should look like, but what's really normal is hard to define necessarily. But when your data kind of has this form to it, where most of it's kind of clustered in the middle, and then it kind of tapers off on the left and right sides pretty evenly, that's considered a normal distribution. And it's symmetrical, okay? It looks like it kind of goes up and then it comes back down. And the reason why it's symmetrical like that is because we use something called the bell-shaped curve to describe this. And how we get to this point, how they describe what a normal distribution should look like, is using what we talked about yesterday with your mean and your standard deviation. Okay, when we look at a normal distribution or we look at a bell curve, the area under the curve, so if I like drew it on top of all my data points, the area underneath is going to be representing the probability. With the total area equal to 1. So at the beginning of this unit, when we talked about different types of probability, and we got into like the two-way tables and we talked about all those frequencies, like the percentages, and we said when we add up all the percentages from our table, they always equal 1 because 100% of the data is represented in the table. The same thing applies to the bell-shaped curve. 100% of your data is going to be distributed in that curve somehow. Okay, now how do we distribute it? Especially if we're talking about it being normal. So when I said that this is all based off of your mean and your standard deviation, how they distribute the curve is going to play into those 2 numbers. So you're going to need to know what the mean is and then be able to understand how many deviations are we away from the mean? Are we a full 1 away, 2 away, 3 away? And we found that stuff yesterday. But approximately 68.2% of the data is going to fall within 1 standard deviation of the mean. Okay, and then the next one is approximately 95.4% of your data is going to fall within 2 standard deviations of the mean. Again, this is just kind of like parameters of if you know your mean is like 100 and you had a standard deviation of like 5, then you know that most of the data is going to be kind of in this range surrounding 100. And then approximately 99.8% of your data is going to be within 3 standard deviations of the mean. So you can see down below, they have a picture of this bell curve. And I'm going to kind of fill in like what specifically percentage-wise goes into each kind of cluster or each kind of group here. And these are the numbers that we're going to use a lot when we're doing a bell curve, because if it's a normal distribution, they should all act like this. They should all have these numbers on the inside. So how do we get there? Well, we start out with that 68.2. Okay, if I were to divide 68.2 in half, each one would get 34.1, and that's within one standard deviation away. So like the mean is going to be in the middle of your curve. So on the left side of the mean is going to be 34.1%, and on the right side of the mean is also going to be 34.1%. Then as you start to get more farther away from the mean, you start to go out more standard deviations. That percentage is increasing, okay? But we don't just continue to take like 95.4 and divide by 2, because some of that is already represented underneath our curve. So we don't want to double count that stuff. So after the 34.1s, in each next column is going to be 13.6. And then the next ones are both going to be 2.2. Okay, and so those numbers together, if I were to add them, should get you that 99.8%. So like that's what they set up above, that most of the data should be within 3 standard deviations away from the mean. But sometimes we have those outliers that really affect the data and they skew it. And that's going to be this remaining 0.1%. So each of these little tails gets 0.1. So if you can squeeze it in there, you can, or you can always write it out on the outside if it starts to get too small. So as we start these problems, we're going to set up the bottom of the graph with the mean and the standard deviation information that they give us, because that just lets us know kind of what numbers we're working with. And then we can always fill out underneath the standard curve with these percentage points, and then we'll start answering questions. And today your answers are going to probably be mostly in percentages, because that's what we're working with our bell curve. Sometimes they'll ask you like how many people, and then we'll have to convert the percent to an actual number representing people. So let's do an example here together. So right underneath this, it says that we've got the weights of 50 football players that have a mean, so right down here, a mean of 178 pounds and a standard deviation of 8 pounds. Your mean always goes in the middle. So the 178 is going to go to that middle dotted line right underneath it. Okay, now to set up your standard deviations, it says that one single standard deviation is 8 pounds. So that means on either side, when you're one deviation away, you're up 8 pounds or you're down 8 pounds from the mean. So up 8 pounds from 178 would be 186. Down 8 pounds would be 170. Okay, so that each of those would be one deviation away. Now, as you get farther away, those numbers are going to continue to increase or decrease by the same amount. So you're just going to go up by 8 to fill out the right side, or you're going to go down by 8 for this one to go to the left. So down 8 from 170 would be 162, and then down 8 more would be 154. And then up 8 would be 194, and then 202. Okay, so now on the far right, we have questions about the bell curve. And they're asking you, like, how much of the data is in between a specified weight group? And that's why we had to fill out the bottom first, so that we kind of know I'm talking from this point to this point. So the first one wants to know what percent of players weigh between 178 pounds and 194 pounds. Make sure you read the problems carefully so you know if it's like a combined amount or if it's just one certain area or if you're going less than or greater than. This one wants you to go between 178, which would be right here, and 194, which would be right here. So you don't have to do that, but I'm just kind of outlining where it would be. Okay, now to get our percentages, remember those percents that we wrote up above? We need to copy them down onto this bell curve so we can actually start doing the math. So those numbers don't change. So 34.1, 13.6, 2.2, and 0.1. You'll probably write those numbers so much when you're doing this kind of stuff that eventually you'll have them memorized. Okay, So, like I said, with my blue lines, the data I'm focused on is in between those two blue lines. So to get the total percentage, I just have to add them. So I'm just going to add 34.1 plus 13.6. What is that together? 47.7. And this is percent. So 47.7% of the data, or of the football players, should have a weight between 178 and 194. Okay, I'm just going to erase those lines so we can start over for the next one. So next, letter B says, what is the probability that a player weighs at most 170 pounds? What does like at most mean? That's the max. Like you can't go over 170 pounds. So 170 is right here. And I want everything less than that. So I want everything to the right of that line because that's like my maximum amount. So I'm going to add the 0.1, the 2.2, and the 13.6 together. What does that come out to be total? 15.9. Good, 15.9%. Okay? This shouldn't be super hard. Okay? You're just adding percentages together for the most part. Letter D on this one will be slightly different, and we'll get there. But let's do C first. So C wants probability that a player weighs less than 162 pounds and greater than 194 pounds. So what areas of the graph do I want to focus on here? The left and the right of those like numbers that they gave me. Because it says less than 162, so here's 162, so I want everything to the left. But it also said greater than 194. So I want everything to the right of that as well. So we have to add those four little pieces together. So you're doing 0.1 plus 2.2 and then another set of those. Or you could just do one time and double it since it's the same numbers. What do you get? 4.6. Good, 4.6%. Okay, letter D. Like I said, this one's slightly different because it's not asking about a probability. It's asking about how many players weigh. So I don't want a percentage here. I want like an actual number representing these people. So how many players weigh between 170 pounds and 186 pounds? So let's first go to our curve here. We're between 170 and we're between 186. Okay, so what's my total percentage here? If I add those together, what's my percent? 68.2. Okay, but that's a percent. I want a number to represent people here. So if I have a percentage of people, we then go back and figure out how many total people were represented in this graph. Yeah.
You times by 50.
You times the percentage by 50. Now don't take 68.2 times 50. How do you change a percentage to a decimal so you can actually work with it?
0.682.
Yes, you move the decimal 2 places to the left. Okay, so you're really going to be taking 0.682 times 50. Okay, so 0.682 times 50, we get 34.1. We're talking about people here though, guys, so we have to have whole numbers for people. How many people would this best represent?
34.
34. So we're just going to round that down. So 34 players should be in that weight group. Does that make sense so far how we're doing that?
Yeah.
Okay, so let's flip our page over here. And I think I'm gonna skip over 2 for right now and go to 3, just because we're on limited time. And I want to give you guys time to practice, but I don't want it to just be whole numbers all the time, because sometimes you're going to have situations where you're dealing with decimals. So let's skip down to 3 because we're talking about the price of a gallon of regular gasoline. So it says the price of a gallon of regular gasoline at 75 gas stations across the state is normally distributed with a mean of $2.05 and a standard deviation of 4 cents. All right, so what number do we put in the center of our graph? What's the mean?
$2.05.
$2.05. Okay, now because these numbers are getting kind of decimals and all that stuff involved, I'm going to switch this and I'm going to write it sideways. So you guys can do that if you need to save some space because it gets really hard to cram stuff in on these pictures. Okay, now what my standard deviation is 4 cents. Okay, so think about you're subtracting 4 pennies or adding 4 pennies each time. So if we fill out the top, if we add 4 pennies each time, it's 2.09, 2.13, and 2.17. What would be my lower numbers? What would be 4 cents less than $2.05?
Oh, my bad.
That's this one, yep. This one would be 2.01, and this last one, 1.93. Okay. Now the percentages on the inside are the same. Okay, so I'm just going to copy those down. 34.1 goes in the middle two. Then your 13.6, 2.2, and 0.1. Okay. Now, I want you guys to read through A, B, C, and D. I'm going to give you a couple minutes. I want to see what you can do with it. We've done one together. See if you can do what we did on that last one, but using your new standard curve. Okay. Part A says, what percent of gas stations sell a gallon of gas for less than $1.97? What did you guys say? What did you get for an answer there?
15.9%.
15.9%? Anyone get something different or agree with Caden? I'm sorry, Caden, but I don't agree with you.
Wrong.
For A, what'd you get? I got 2.3 as well.
2.01. My bad.
It's all right. So less than 197. So here's our kind of barrier, and we go to the left. So the 2.2 plus the 0.1 is where we're getting that 2.3% from. How about for B? What percent of gas stations sell a gallon for at least $2.17? It's 0.1. Okay. Again, that wording in there, like at least, you have to know what that means to understand what side of the graph am I looking at. at least would be like that's the minimum. So the minimum is $2.17, and so I want anything above that, which is only that 0.1%. So most gas stations are going to have something smaller than that for their cost. Okay, C, what is the probability that a gas station sells a gallon of regular gas for less than $1.97 or greater than $2.05? What'd you get for an answer?
52.3.
I agree, 52.3. Okay, because again, you're going less than $1.97, so all of these numbers to the left of that get added, and then greater than 205. So you add all of those other numbers on the right. The other thing you could do, guys, if you kind of understand how, there's 100% of the data in here, you could take 100 and subtract the two that you're not using. Like I'm not using this 34.1 and 13.6. So if I take 100 and I subtract those, I should still be at 52.3%. So that would just be another way you could approach that problem. Okay, how about for D? How many gas stations sell a gallon of gas for no more than $2.01? How'd you guys handle this one? You got 12? How'd you do it? Can you tell me what you added together for your percentages?
I did 13.6 plus 2.2 plus 0.1, and then I changed that to like 0.159.
Yep.
And then I multiplied by 75, and I got 11.92, and I rounded it up to 12.
That sounds good to me. Everyone agree? Again, being able to read and understand the wording, like when you see things like no more than or less than or greater than, you have to know where exactly on the table or on the bell curve you're looking in order to add the correct numbers together. All right, do we have any questions on that? I know I skipped over 2, but we got a short period today and I want to give you guys time to work. Okay?